In this video we are going to see the derivative of square root of x. Okay, to get the derivative of square root of x, we can use the power rule of derivative. That is, for example, if you have a function like y is equal to x to the power of n, here on the right side the base is a variable and the exponent is a constant. In any function, if the base is a variable and the exponent is a constant, we can use the power rule of derivative. That is, I find derivative on both sides with respect to x. If you find the derivative of y with respect to x, it will be dy over dx. To get the derivative of this one, what we need to do is you have to bring this exponent in front of the variable and then you have to subtract 1 from the exponent. So this is the power rule of derivative. So I am going to use this power rule to get derivative of square root of x. So let us see how it is. Okay, so before we use the power rule to find the derivative of the given function y is equal to square root of x, first I have to write this square root as exponent. We all know that if we write the square root as an exponent, it will be 1/2. Okay, now we can use the power rule of derivative. That is, in this function I am going to find derivative both sides with respect to x. So I get dy over dx. That is, if I find derivative of y with respect to x, it will be dy over dx. Okay, here I can use the power rule of derivative. The base here is x, the variable, and the exponent is a constant, that is 1/2. So to get the derivative of this one, we have to bring the exponent in front of the variable and subtract 1 from the exponent. So now we get dy over dx is equal to 1/2 times x to the power of, if you subtract 1 from 1/2, the answer will be negative 1/2. I think you all know about this one because 1/2 negative 1. So we can assume there is denominator 1, we can multiply both numerator and denominator by 2. So because I will be able to subtract a fraction with another fraction when both the fractions have the same denominator. So I assume this 1 also as a fraction. So since I need to have the same denominator 2 for both the fractions, I multiply both numerator and denominator here by 2. I get 1/2 negative 2 over 2, which is equal to 1 negative 2 over 2. So here the two fractions have the same denominator, so I take the denominator once and subtract the numerators. So 1 minus 2 is minus 1 divided by 2. So 1/2 minus 1 is equal to negative 1/2. Okay, so in the next step what we can do is dy over dx is equal to, here the exponent is negative. So we can make this exponent as positive by moving the whole term x to the power of negative 1/2 to the denominator. Then we get 1 over 2 times x to the power of 1/2. Okay, so here the x is having the power 1/2. Whenever the power is 1/2, it can be changed as square root, because even in the beginning of the problem we have done this. So we had square root, we changed the square root as exponent 1/2. Here we have exponent 1/2, it can be changed as square root. So finally dy over dx is equal to 1 over 2 times square root of x. So the derivative of square root of x is 1 over 2 times square root of x. We can approach the derivative of square root of x using chain rule. Just now we got the derivative of square root of x. That is, if y is equal to square root of x, and its derivative with respect to x will be dy over dx is equal to 1 over 2 times square root of x. So far we got derivative only for square root of x. By chain rule, further we have to find the derivative of the stuff we have inside the square root. Here we have x inside the square root. By chain rule, if you find the derivative of this x with respect to x, it will be 1. So this result has to be multiplied by 1. Then 1 over 2 times square root of x times 1 will be the same, 1 over 2 times square root of x. So this is how we can approach the derivative of square root of x using chain rule. So whenever you find derivative of a square root function, you have to put 1 in numerator and 2 times whatever stuff you have here the same should be multiplied by 2 in denominator. Further you have to find the derivative of the stuff what we have inside the square root. Okay, let's look at another example. For example, y is equal to square root of 2x. When you find derivative of this one, dy over dx is equal to, you have to take 1 in numerator and take 2 in denominator and multiply this 2 by square root of 2x. So then you get 1 over 2 times square root of 2x. So far you have found derivative only for square root of 2x. Further, you have to find the derivative of this stuff we have inside the square, that is 2x. When you find the derivative of 2x, it will be 2 times 1, because when you find the derivative of 2x, you have to keep these 2 constant as it is. You have to find the derivative of this x with respect to x, it is just 1. So this 2 will cancel out. We get dy over dx is equal to 1 times 1, which is 1 over square root of 2x. Let's look at another example. Consider y is equal to square root of x cube. Okay, now I have to find the derivative of this one with respect to x. So on the left side we have y. When I find derivative of y with respect to x, it will be dy over dx. When I find derivative of square root of x cube on the right side, it will be 1 in numerator, 2 times whatever square root we have, the same has to be multiplied here. So 2 times square root of x to the power of 3. Okay, further we have to find the derivative of the stuff what we have inside the square root by chain rule. So if you find the derivative of the stuff, that is x cube with respect to x, it will be 3x square. Okay, in the next step we can multiply this 1 and 3x square. It will be 3x square divided by 2 times square root of x cube. The square root of x cube can be written as x times x times x. Okay, we all know that whenever we have two same values multiplied inside the square root, 1 will come out. So we can write as 2 times x times square root of x. So for these two x multiplied inside the square root, 1x will come out. Okay, in the next step what we can do is 3 times this x square can be written as x times x. So divided by 2 times x times square root of x. So 1x here will cancel out. Finally that we get 3x over 2 times square root of x. So the derivative of square root of x cube is 3x over 2 times square root of x. Let's look at one more example. Consider y is equal to square root of sin x. Okay, I am going to find derivative of this one with respect to x. So on the left side I will be getting dy over dx. On the right side we have square root, so we have to put 1 in numerator, 2 times whatever square root we have, the same has to be multiplied here. So 2 times square root of sin x. So now by chain rule we have to do further derivative of the stuff what we have inside the square root, that is sin x. Now I have to find the derivative of this sin x with respect to x, that is cosine x. So dy over dx is equal to cosine x, 1 times cosine x will be cosine x over 2 times square root of sin x. In this way we can get the derivative of like y is equal to square root of cosine x. So that is dy over dx is equal to 1 over 2 times square root of cosine x. Okay, by chain rule we have to do the further derivative of cosine x with respect to x, that is negative sin x. So 1 times negative sin x will be negative sin x. So dy over dx is equal to negative sin x over 2 times square root of cosine x. Okay, now we can get the derivative of y is equal to square root of tan x. Okay, so now the derivative of y is dy over dx, and square root of tan x, the derivative of square root of tan x is 1 over 2 times square root of tan x, and by chain rule you have to find the further derivative of tan x with respect to x, that is secant square x. So dy over dx is equal to 1 times secant square x will be secant square x over 2 times square root of tan x. I think this video will be much helpful for the students who study calculus. If you like this video, please subscribe our channel. Thank you.